Hi, welcome to Forever. In this video, we will be implementing the delete methods for a linked list. In the previous video, we have implemented the insert methods and also the print method. We have also seen the importance of a linked list and how is it different from an array. So if you haven't checked that video out, please go ahead and watch that first before moving on to this video. Now we'll get into the delete methods of a linked list. So just like in insert methods, in delete methods we have three methods as well. Okay, the first one is delete from the start. Second one is delete from the end, and the third one is delete from the middle. Okay, so first we'll write the delete from the last method because that is the easiest method, or delete from the first. Delete from the first is also very easy. So in no particular order, we are just going to write the method for deleting elements at the last of a linked list. Okay, so for this as well, you don't need to return anything. So you can just have a method by void data type. And I'm just going to name this method as delete last, and you don't have to get any arguments for this because we're just going to delete the last element. Okay, so delete last is the name of the method, and our trusty temp variable, we are initializing it to head, and we are going to go to the second last element. Okay, that is the point to note. You are going to delete the last element, so you don't have to be at the last element. If you are going to delete the last element and you be in the last element, that is not how things work and that should not be done. So you have to be in the previous element or the second last element. So we are going to use a similar while loop to the previous insert method, and the condition that we are going to give is quite different. So what I given is temp.next not equal to null. Okay, so I have given couple of .next. So if temp.next, that is the previous condition that we have been using, not equals null is the condition that we are going to use here. That is, if while temp.next not equals null, that will end us up in the last node. Okay, only for the last node temp.next will be null. So if we use that condition here, the temp variable will end up at the last node, and we don't want that because we are going to delete that node. So we'll have to be in the second last node. So temp.next not equal to null is the condition that we are going to use. So the next node's next reference should not be null. So if I am at the second node, the third node's reference shouldn't be null is the condition. Okay, so temp.next not equals null. So until this condition, we are going to give temp equal to temp.next. Okay, so we are moving to the last element, and at this position we are at the second last element, and what you have to do is just assign temp.next equals null, and that's it. Let me explain you why. We are at the second last element and we are going to delete the last element. So what we are going to do is we are going to make the second last element's reference as null. Okay, temp.next at the current position, we are at the second last position, temp.next is going to point to the last element. We are making that reference as null, so it doesn't point to any element, and that will become the last node of this linked list. Now what will happen to the previous last node that you have just dereferenced? You have to note the word dereferenced. Whenever a pointer or whenever a memory in Java doesn't have a reference, it will be collected by the garbage collector. So you don't have to use the delete keyword or do anything like that. You just have to dereference it and it will be collected automatically. So we have just given temp.next equals null, and that is it. So this particular method will delete nodes from the last of the linked list, and now we'll check if it works properly. So this is the linked list that we had previously, right? I'm just going to call the delete method. So this should delete the last node. So before doing that, let me just make sure what the list should be. Okay, we'll just run this without the delete method. The list is 18, 5, 1 and 3. So if we use this delete method, the 3 shouldn't be there, right? Okay, now I'm running this again, and 18, 5 and 1, we don't have the 3. So the delete method is working fine. It is deleting the element from the last node of the linked list. Now we have to write a couple of more delete functions. So we have written the delete last method. Now we'll write another method called delete friend. Okay, so what will this do? This will delete nodes at the front of the linked list or at the start of the linked list. So this will delete our current head node and make the second node as the head node. So that is exactly what we are going to do here. We are just going to make head equals head.next, and that's it. So the head node currently is pointing to the first node of the linked list, and we are going to make the head node or the head reference point to the second node of the linked list. Okay, so in that case the first node is getting dereferenced. We don't have any reference to the first node, so that will be deleted automatically. Okay, it will be collected by the garbage collector. So this is the method that we are going to use for delete friend. It's very simple, head equals head.next. I hope you understood this. Now we'll check this. Okay, delete friend, right? Delete friend. So in the previous example we had 18 as the first node, and now we shouldn't have 18. Okay, we are also having the delete last method, so the last and the first, both these nodes should be deleted. Okay, 18 was the previous first node and we don't have it now, and we don't have 3 either because we also have the delete last method called. So we have deleted the front element as well. So I've written the delete last and delete front methods. The last method that you are going to write is called delete middle. Okay, void delete middle, and this is going to get an argument which is the position. Okay, which is the position of the node that you want to delete. We are going to get the position of the node. So if we want to delete third position, 3 will be the value of position that we are going to get as argument. Okay, now this is quite complicated when compared to the other two methods that you have written so far. Okay, so let us say we have to delete the third node. What we have to do is we have to get to the second node. That is what we always do, right? If we have to delete a node, we have to be at the previous node. So if we have to delete the third node, we have to go to the second node and make its reference point to the fourth node, because we are going to delete the third node. So make the second node's reference point to the fourth node. That is what we are going to do here. Okay, so as usual we are going to create our temp variable and make it point to head. Okay, now what we are going to do is we have to move this temp variable to the previous position or the position before the node that is going to be deleted. So if the value of position is 5, you have to move the temp variable to the second position, and just like we saw with the insert middle, for that we have to give the position -2 condition, I equal to 0, I less than position -2. Okay, as we already saw, we have to give position -2 because position is 3. We have to be at second node and we are currently at the first node. So we just have to move the value of temp only once. I'll just repeat that once again. We are going to delete the node at third index, or I mean not index, we are not using array, we are in the linked list. So we are going to delete the node at the third position. For that we have to be at the second position. We are currently at the first position. So to move to the second position, we just have to move the temp reference only once. So I hope this is clear. We are going to move to the second position or the second node. For that we have to move the temp reference only once. Okay, so for that we are using the condition position -2. So at the end of this loop we will be pointing at the second node and we have to delete the third node. So we will just make the reference of the second node point to the fourth node. In that situation, the third node, the current third node will be dereferenced and it will automatically be garbage collected. Okay, so temp.next, that is the second node's reference, is going to point to temp.next dot next. Okay, I'll just explain this a bit more carefully. So we are at the second position. Okay, we have to make this reference point to the fourth position or the node at the fourth position. Okay, so temp.next is currently pointing to third index or the third node. So temp.next will be pointing to the fourth node. Okay, temp is currently at the second node. So temp.next will be third node and temp.next will be the fourth node. So we are just making the fourth node as second node's reference. I hope this is clear. So temp.next is equal to temp.next.next. Okay, so by this particular statement we have made the third node dereferenced and that will be garbage collected automatically. So this is the delete middle method. I'll just repeat this once again because I'm not entirely sure if you got this. We are going to delete the third node. For that we have to be at the second node. Okay, so we have used this for loop to get to the second node and we are at the second node. We are going to delete the third node. So what we'll do is we'll make the second node's reference point to the fourth node. That is how we are going to make this third node out of the linked list. Okay, 3, 4, 5 or 2, 3, 4, and that is the connection. That is how the connection is right now. We are connecting 2 with 4 directly, leaving 3 out of the loop. Okay, by this we'll make 3 unreferenced or dereferenced and it will be collected by the garbage collector. So that is what we have done here. And now we'll see if this works fine. So I'll not write these other two delete methods and we'll see delete dot list dot delete middle of. We'll try and delete the third node. Before that I'll see what the third node is. Okay, now we are running without the delete method and 18, 5, 1 and 3 is what we get. So the node that should be deleted is 1. Okay, now I am uncommenting it and running it again and we don't have 1 in the answer. 18, 5 and 3. We have deleted the third node successfully. So these are the delete methods for a linked list. So we have seen the insert methods that inserts node at the front, last and in the middle. We have also seen the delete methods that deletes a method that deletes nodes at the front and at the last and also in the middle. Now we can write one more method for the linked list, that is search method. Okay, this search method will see if a node is present in the linked list and returns 1 if it is present or the position, whichever you like, you can return it, and it returns -1 if the node is not present in the linked list. And this is how we are going to write the search method. It is just going to return an int because you are going to return if the node is present or not or the position of it, right? So the return type will be int and search will be the name. We are going to get the data. Okay, we are going to see if a particular node is present, right? So you have to know the data we are searching for in order to see if it is present or not. So we are going to get the data as the argument, and as usual we are going to create a temporary reference and we are going to make it point to the head. Okay, we have done that. Now we are going to traverse through the linked list while temp dot next not equals null. So until the last node is reached, we are going to move the temp pointer, but before that we are going to check if the current node has the data. If temp dot data equal to data. Okay, so this is going to check if the current node's data is in fact the data that we are searching for. If it is so, we are just returning 1 for this, okay, saying that the data is present here. If it is not, you don't have to give the else statement because it is going to return and it will get out of the function. So you can just write temp.next or temp equals temp.next. So we are moving the temp reference to the next index, and if the control of the program comes out of this while loop, it means that we have reached the end of the linked list and we didn't encounter the data that we are searching for. In that case, we are just going to return 0. Okay. Now we'll see if this is working. Now in the main function, I'm not going to delete anything. I'm just going to search list dot search of let me just search 18. Okay, and I'll just try and print this system dot out dot println. Okay, now we are going to search 18, and we know that 18 is present, right, because we have inserted 18 in it. So this should print 1. Okay, and let us see what is printing. It is printing 1. Okay, the first line is 1, and later we have just printed the linked list, and that doesn't bother us right now. So we are searching if 18 is present, and it in fact is printing 1, so 18 is present. Now I just have one question. I'm not sure if it is checking the last node, so I'll just check if the last node is being checked in fact. So I'll see if 3 is present, right, because 3 was the last node. Okay, so I'll see if 3 is present. If it is working, it is fine. If it is not, we'll just have to change the code, and we have to change the code because it is saying that 3 is not present, but we exactly know that 3 is present, right? Right, because if we print the linked list, we can see that 3 is present. 3 is at the last, so we have done something wrong, so that it is not checking the last node. And what exactly is that? We have given temp.next not equals null, so when coming to the last node, it will come out of the loop. Okay, so for the last node, we haven't checked if its data is in fact the data that we are searching for. So instead of temp.next equals null, I'm just going to give temp not equals null. So this should be working fine. Now we are again, so oh no, I haven't searched it. Okay, now we are searching for 3 again, and this time it should say 1, that 3 is in fact present here, and that is what we are going to give. So this is the search method. So the slight mistake that we did earlier, or it is not slight, we are not checking the last thing, and that is an edge case that we failed, and I'm owning it. Okay, so the mistake was I checked temp.next not equals null, so that doesn't check the last node, because last node's next will be null, so it will come out of the loop. Okay, so in that case it will not go into the loop, so that we haven't checked the if condition. So what we have done is temp not equals null. So this means only if it goes out of the linked list, it will come out of the loop, and that is when we are going to return 0. So keep an eye on this particular condition and do it correctly. Don't make that mistake. So that is all the functions that we need to implement a linked list. So we have insert functions which inserts nodes at the front, at the last, also at the middle. We have delete functions that deletes nodes at the front, at the last, and also in the middle. We also have the search function that searches if a particular data is present in the linked list and returns 1, and it returns 0 if it is not present in the linked list. So this is all the methods that we need for a linked list. And the reason that we have written everything inside a linked list class and we have used object-oriented programming for this is that you can create multiple instances of the linked list and use it easily. So here we have one linked list by the name of list. I can go ahead and create list 2 or list 3 or anything, new linked list. Okay, so I've created a list 3 and I can insert I can very well insert values into list 3 as well. Okay, it doesn't bother with the other list. So this is the advantage of using object oriented programming or classes for that matter, because it allows code reusability. So I have one class linked list which has everything that corresponds to a linked list. It has the node class inside it, it has the head node, it also has the functions that can act on the linked list. Everything is packaged into this one class. Encapsulation, as we say in object-oriented programming, and we can use that easily to create any number of lists that we want. And that is the end of the linked list episode. So if you haven't checked the previous one, go ahead and check it right now. You should have checked it before checking this video out. But anyways, I hope you understood everything. If you have any questions, please let me know in the comments and I'll get back to you as soon as possible. And for more videos like this, like and consider subscribing to Codevo. Thank you so much for watching. See you in another video. Bye.